Today's lesson on solving quadratic equations by factoring. So this is going to use techniques that we have previously learned to solve equations now. So first off, we need to know, what is a quadratic equation? Well, it's an equation that can be written somewhat in this form: ax squared plus bx plus c equals 0, where a, b, and c are constants. Those are just numbers. Oops, that's a C there, where A, B, and C are constants. So it's a polynomial, and technically this is called degree 2. It's called a polynomial of degree 2, or second degree. And that's because the highest power you'll see in a quadratic is 2. Okay, now it doesn't always have all three terms because one of these constants could be 0. A, B, or C could be 0. Now if A is 0, then that means this first term goes away, in which case you no longer have a quadratic, because then the highest power would be x. So you would have a linear equation, which is probably what you're used to dealing with. But the idea is, how do we solve equations like this for x? Okay, a polynomial that's written in standard form is one where the highest power of x comes first. So for example, so it's written with the highest power first and decreasing powers after that. So it's just referring to the order of these three terms here. So for example, one that's in standard form would look like maybe this: 3x squared minus 2x plus 5 equals 0. One that's not in standard form might look like this. It might say 7x minus 5 plus 3x squared equals 0. So this is a quadratic equation. It's just not in the standard order because the 3x squared is last instead of first. Okay, so what we'll do is we'll usually write things in standard order or in the standard form. That way you get used to seeing it the same way every time. Okay, so what we're going to do is solve equations like this. Now before we do, I need to ask you an important question. If you have something like this, an equation that says a times b equals 12, can you determine necessarily what a and b are? Okay, and I'm sure you can think of some ideas, right? You might say a could be 3, in which case b would be 4. That's one solution. But really, there's infinitely many solutions, because a could be 2, b could be 6, a could be 1.5, in which case b would also have to be a decimal number. There's infinitely many fractions and decimals that a and b could be, and they could also both be positive or they could both be negative to make this equation true. Okay, so that's the infinity sign, but there are infinitely many solutions. So you can't come up with a single answer here for this equation. However, if you have the same thing but it's equal to 0, so if you have a times b equals 0, then is it possible to determine what a or b could be? And here the answer is yes. Okay, so up here the answer is actually no. But the answer is yes here, because an equation, a product, can only equal 0 if one of the factors is equal to 0. So either a would have to be 0 or b would have to be 0 in order for their product to equal 0. And if either of those things is true, then this equation is true. So both of these solve this equation. If either one of those is true, they don't both have to be true, but if at least one of them is true, this equation is solved. Okay, and that's what the zero factor theorem is about. The zero factor theorem says if a and b are real numbers, that means positive, negative, decimals, fractions, whole numbers, just real numbers. And if a times b is equal to 0, then either a equals 0 or b equals 0. Okay, so that is the zero factor theorem. We're going to use that throughout this section. So now that we have that, we can solve our first quadratic equation. Now the way it's written, this is not in standard form because it's factored. Okay, now if you were to multiply this out, you would get a quadratic though, because you would FOIL and you would get x squared plus 2x minus 7x would be minus 5x, and then the last two terms would give you minus 14. So it is a quadratic. Okay, I only did that to show you that it is a quadratic, but that isn't actually part of the problem. Okay, to solve this, let's use the zero factor theorem because this is a product. We have x minus 7, that's one factor, times the second factor, x plus 2, and it's equal to 0. Now the zero factor theorem only works if it's equal to 0, in which case you can set each factor equal to 0, because here what we did is we set a equal to 0 and then we set b equal to 0 here. So if either of those factors is equal to 0, then this equation will be true. So we set each factor equal to 0. Now it has to be factored for this to work, because this only works if it's a product, if you're multiplying a times b. So we set each factor equal to 0. So our first factor is x minus 7. Set that equal to 0. Our second factor is x plus 2. So we'll set that equal to 0. And then we solve each of those equations. So x minus 7 equals 0. Adding 7 to both sides, we get x equals 7. And adding or subtracting 2 from both sides, we get x equals negative 2 over here. So those are the two solutions to this equation, because if x equals 7, let's check here. If x is equal to 7, if we plug that into the original equation, I want to see if it's true. We'd have 7 minus 7 times 7 plus 2. Does that equal 0? And the answer is yes, because this is 0 times 9, which is 0. So if x is 7, this equation is true. So that is a solution. Or if x is equal to negative 2 and we plug that in, we'd have negative 2 minus 7 times negative 2 plus 2, which is negative 9 times 0, which is also 0. So that also solves the equation. Okay, so sometimes equations have two answers. Now, not every quadratic equation does, but oftentimes they do. Okay, here's another one. Now you have to think, is this a quadratic? And the answer is yes. If you expanded that x out, you'd have 4x squared minus 3x, which is a quadratic. Okay, so, but it's already factored, which is what we want. We want it factored and equal to 0. That way we can use this zero factor theorem. So because it's already factored, we set each factor equal to 0. The first factor is just that x, and there's nothing to solve. That actually gives us an answer right there. It's already solved for x. And then the second factor is 4x minus 3. So if we set that equal to 0, then we solve for x. So we add 3 to both sides and divide both sides by 4. And we get x equals 3/4 as our second solution. Okay, now this one is another example. This is written in standard form, this quadratic here is. However, it doesn't help us to solve because we can only use this zero factor theorem up here. Sorry, I clicked on the wrong thing there. Here it is. We can only use the zero factor theorem if it is factored and you have a times in the middle. So in order to solve this, we first have to factor. So let's see if we can break down the x squared minus 3x minus 18 into two factors. Now it's a trinomial, so it should factor into a product of two binomials, and it's equal to 0, so do make sure you write that. The x squared will break down into x and x. Let's see, negative 18. 18 breaks down into 6 and 3, so if we do negative 6 and positive 3, then the outside and inside terms should add to negative 3x. So if we FOIL that out to check, you will get what we started with here. But now it's factored, so we can set each factor equal to 0 and then solve each of those for x. So the first factor gives me an answer of 6, and the second factor gives me an answer of negative 3. Okay, and here's another one. Now again, you have to ask, is this a quadratic? And the answer is yes. We have a squared term, we have an x term, and a constant term. However, there's two things here. For one, it's not factored, and two, it's not equal to 0 either. Okay, so here's what you don't do. This is one of the most common mistakes. Okay, this would be the wrong way to do it. Would be to only factor the left side. And a lot of people will try this. They'll say, well, both of these have an x, so I can take an x out. And then they're left with 25x minus 29 equals negative 4. And then what they do from here is they set each factor equal to negative 4 because that's what's on the other side. Now you cannot do that. The only reason the zero factor theorem works, remember, is because it's equal to 0. If you have a product, let me come back up here, if you have a product is equal to a number, you can't solve that equation. This factor, the first factor A and the second factor B, could be anything. There's infinitely many solutions. So this does not work, so do not do that. Okay, instead you have to make it equal to 0 first before you can factor, before you can do anything else. So to get it equal to 0, all we need to do in this case is add 4 to both sides. So we'll have 25x squared minus 25x plus 4 equals 0. And now we factor. Let's see, 25x squared breaks down into something times x and something times x. I'm going to try 5x and 5x. Okay, 4 breaks down into 2 and 2, and both terms will have to be negative to give us that negative there. So let's try this and see if that works. So now we have to check and refoil here, make sure we got it right. So we have 5x times 5x is 25x squared. These outside terms are 5x and negative 2 is negative 10x. The inside terms are the same, and the last terms are 4. But that did not work because negative 10x minus 10x is negative 20x, not negative 29x. So I need to back up here. If I'm going to get 29x here in the middle, how about multiplying 5 and 5 together? That would be more likely to get us there. But there's no way to write it so that we have both a 5 here and a 5 there, because then the last term wouldn't multiply to 4. So what if we wrote the first two terms in terms of 25x and 1x instead of 5x and 5x? That should help us get a much bigger number like 29x in the middle. So 25 plus 4 is 29. So somehow I want to add a 25x to a 4x. So if I put the 4 here, then I would be multiplying 24x times 4 when I do the outside term, which would give me 100x, which is way too big. So let's try putting the 4 here, and they both have to be negative, and let's put a 1 there. Okay, so then when we FOIL, we'd get 25x squared minus 25x for the outside terms, minus 4x for the inside terms, and negative 4 times negative 1 is plus positive 4. That works. Negative 25x minus 4x is negative 29x. So now that we have that, now we can keep going and solve this equation by setting each factor equal to 0. So setting 25x minus 4 equal to 0, and we set x minus 1 equal to 0. And we solve each of these. So solving the first equation, we add 4 to both sides, and then divide both sides by 25. Oops. So we get x equals 4 over 25, and on this other one, we just add 1 to both sides to get x equals 1. Now, one of the things I should mention here is you really should start winning yourself away from doing this. What a lot of students do is they'll show these baby steps here. They'll write plus 4 to add 4 to both sides. And then these cancel, so you have 25x equals positive 4. Really, you should be to the point where you no longer need to do that to write the plus 4 and plus 4. If you're not there, just start winning yourself away from it. Okay, if you have a minus 4 on one side, you add 4 to both sides, it's going to become positive 4 on the other side. Or if you divide both sides by a number, you should be able to see in your head what it's going to look like, how this is going to be 4 over 25 without actually having to write over 25 over 25 every single time. Now if you need to write it, okay? If that helps you solve the problem, I'm not saying you shouldn't. But you should be getting to the point where you can skip those steps because it does make your paper pretty messy. And actually, I think it makes it harder for you to see what's really going on, especially when we get to the longer problems. Okay, so moving on, let's solve another one here. X times x minus 4 equals 5. So again, what you don't do is set each factor equal to 5 because that zero factor theorem only works if it's equal to 0. So we have to get it equal to 0 on one side. So let's move the 5 over. So we'll have x times x minus 4 minus 5 equals 0. And so then you say, well, is this factored? No, it's not factored because we have this minus here. It's only factored if the pluses and minuses are all inside parentheses, so that every term is being multiplied. But we actually have two different terms here that are being subtracted. We have 5 and this x times x minus 4. So we have to factor it, and it's sort of semi-factored here because this x is factored out of these parentheses, but that isn't going to help us factor the quadratic as a whole. So before we can factor, we actually have to re-expand that x out. So we have x squared minus 4x minus 5 equals 0. And now it's in standard form, so now we can factor using techniques you know. So let's see. We get x and x. Negative 5 breaks down into 5 and 1, and I will put the negative sign with the 5 so that we'll end up with negative 4x in the middle. So when you refoil this, you will get negative 4x. And then we set each factor equal to 0. So we'll set x minus 5 equal to 0. And we'll set x plus 1 equal to 0 and solve each of those. So we get x equals 5 and x equals negative 1. Okay, and notice how I drew this little arrow here? It's a real good idea if you kind of jump around your page a little bit to draw arrows so that I can follow where you stopped one step and where you went next, and so that when you look back on your own work, you can figure it out too. So don't hesitate to draw little arrows so that you and I can both follow your work. Okay, let's do another one. Now this one is in standard form, and we could try to factor it as it is, but that looks hard because of two things. For one, the numbers are kind of big, and two, there's a negative in front of the first coefficient, the first term, which we're not used to dealing with. So maybe we should factor out a negative. And if we're going to factor out a negative from all the terms, we might as well see if anything else factors out of all three of those terms. And if you look at it, 5 is also a factor of 20 and 60. So we can take out a negative 5 from everything. And we'd be left with x squared minus 4x minus 12 is equal to 0. And then from here, well, we do want to factor this quadratic, but we have this negative 5 hanging out. So to get that out of the way, all you have to do is divide both sides by negative 5. Now this is one of those times where I am actually writing the divide by negative 5 because I want you to see very clearly what I'm doing here. So if we do that, the negative 5's cancel, and then 0 divided by negative 5 is 0. So we have x squared minus 4x minus 12 equals 0. Now to me, this looks a lot easier to factor than this original problem up here. So let's see if we can factor that. X squared breaks down into x and x. 12 breaks down into 4 and 3. Now if I do 4 and 3, there's no way to make them add to negative 4. So another way 12 breaks down is to 6 and 2. Now I can add 6 and 2 to get 4. So let's use 6 and 2. Now they have to multiply to a negative number, so one of them has to be negative and one has to be positive. And they have to add to a negative number, so the bigger one needs to be negative and the smaller number needs to be positive. Okay, now it's factored, it's equal to 0, so we can set each factor equal to 0 and solve. And so we get x equals 6 and x equals negative 2. And let's do one more that's similar to this. This one, it has only two terms, and it's not a quadratic either. This is called a cubic equation here because the highest degree is power of 3. So we actually don't know how to solve cubic equations, and that's not something that we're going to learn how to do either, unless it's an easy one to solve, like this one. Now this one, you can make it into an easier equation by asking, what can I factor out of both terms? What's the greatest common factor between 2x cubed and 18x? And they both have an x that we can take out, and they also both have a 2 that we can take out. So if we take out a 2x, we're left with x squared minus 9x. Oops, no, minus 9 equals 0. Now that's easier to solve. Now at this step, we can either keep factoring this x squared minus 9, so there's really 2 ways to do this, and I'll do it both ways, or we can set each factor equal to 0 at this point and go from there. So what I recommend doing, though, is always factoring as much as possible. Okay, you'll see why, we'll learn why later in this course, why solving the other way leads you to make, it's more likely to lead you to make errors. So at this point, you say, okay, it's factored, but can I factor any more? Can you factor x squared minus 9? And you should hopefully recognize that as a difference of 2 squares. This is the same as x squared minus 3 squared from one of the previous sections. So I'm carrying the 2x along. And then the x squared minus 3 squared will factor into x plus 3 times x minus 3 by that difference of squares formula. Now it's really factored. We actually have 3 terms here. We can group the 2 with the x, which would give us 2x as one term, or one factor. X plus 3 is another factor, and x minus 3 is the third factor. And it's all equal to 0. Well, the zero product principle works no matter how many factors you have. So this time we set all 3 factors equal to 0. And solve for x. So dividing both sides by 2 over here, I'm going to show you so you don't get confused. The 2's cancel, and we get x equals 0 divided by 2 is 0. Solving this one for x, we get negative 3. And solving this one for x, we get positive 3. Okay, so there are actually 3 solutions to that. Now let's look at this. How many solutions does a quadratic have? In all of these quadratic examples we did, there's 2 answers. 2 answers, 2 answers, 2 answers. Now they don't always have 2 answers. These are just the ones that we have done. But quadratic equations have either 2, 1, or 0 solutions. All the ones we've done have had 2, but you'll see some soon where you only have 1, or 0 solutions. Well, how many solutions did this cubic equation have? The one that has the highest power of x cubed. And you'll notice we got 3 answers. So they can either have 3, 2, 1, or 0 answers also. But the most number of solutions that a quadratic, in other words, something with x squared being the highest power, then the biggest number of solutions it can have is 2. And the largest number of solutions a cubic can have is 3. So whatever that highest power of x is, that's the maximum number of solutions the equation can have. So that's just something neat to point out. So if you're solving a quadratic, I guess, and you get 3 solutions, that cannot be right. Okay, let's do some more here. So let's solve this. We have x plus 3 times 3x squared minus 20x minus 7 equals 0. And what I recommend doing is factoring more completely here, because we're going to have to factor this quadratic. But we could also just go ahead and set each factor equal to 0 too, which was the other way to do this one right here would have been to set each factor equal to 0 at this step. So I'll do it that way on this one, rather than factoring first. So I'm going to go ahead and start by setting x plus 3 equal to 0, and then this whole second factor equal to 0. Because this equation up here is factored, right? All the pluses and minuses are inside parentheses. You have a factor times another factor. So by the zero product principle, you can do this. And then we'll solve each of these for x. Now the first one's easy. You get x equals negative 3. But the second one is harder. So let's see if we can factor this. So 3x squared will only break down into 3x and x. Oops. 7 only breaks down into 7 and 1. Now I want to get a big number, 20 in the middle. So I'm going to put the 7 over here. That way when I multiply my outside terms, 3x plus 7, I'll get 21, which is close to 20. So I'll put the 7 there and the 1 here. They have to multiply to -7, so one of these has to have a minus and one has to have a plus. And I want to get a big negative number in the middle, so I'll put the negative with the 7 because it's bigger, and the plus with the 1. Now let's check and see if that works. If we follow this out, I get 3x squared minus 21x for the outside terms, plus 1x for the inside terms, minus 7. And I did leave off my equals 0, don't do that. Equals 0, copied every time so you don't lose track of what you're doing. Okay, that works because negative 21x plus x is negative 20x. So from here, now we can set each factor equal to 0. So we have 3x plus 1 equals 0, and x minus 7 equals 0. So solving the first equation, we get 3x equals negative 1, so x is negative 1/3. And solving the second equation, we get x equals 7. So there's 3 solutions here, negative 3, negative 1/3, and 7. And of course, you can always check your answer by plugging any of these back ends. For example, if you suspect that maybe one of them is not right, plug it back in up here and see. So we could plug in 7 and see what we get. If we plugged in 7, this is just to check. And let's write which one we're doing. I'm plugging in 7 because there's 3 answers to check. So I plug in 7, I get 7 plus 3 times 3 times 7 squared minus 20 times 7 minus 7. Now we need to compute what that number is. Hopefully it's 0. So we get 10 times, that's from the 7 plus 3 is 10, times 7 squared is 49. 49 times 3, let's see what the calculator here says, is 147. Minus 20 times 7. Now 2 times 7 is 14, so 20 times 7 is 140, and then minus 7. Now 147 minus 140 is 7, minus 7 is 0, so you can check your answers like so. Alright, let's do another one. Now this one is also a cubic because the highest power of x is 3 here, and actually the previous one we did is a cubic as well because if you multiplied every term by every term, your x to the highest power would come from those first 2 terms right there, x times 3x squared, which would be 3x cubed. So this is also a cubic, like this one. And on this one, if you have a cubic, it will factor, either through that sum of 2 cubes factor, difference of 2 cubes factor, or you'll be able to factor out a greatest common factor from all 3 terms, like you can in this one. In this one, they all have a 3 and an x in common. So if we take that out, we're left with x squared minus 3x minus 4, it looks like. So it's factored. Now this one I'm going to keep factoring before I set each factor equal to 0. And it's really your choice. You could set each factor equal to 0 at this step. So x squared will break down into x and x. Negative 4 breaks down into 2 and 2, but if I do that I won't get a 3 in the middle. So let's break 4 down into 4 and 1. And I want a negative in front of that 3x, so let's make the negative, put the negative in front of the 4 and the positive in front of the 1. And now let's set each factor equal to 0. So we have 3x equals 0, x minus 4 equals 0, and x plus 1 equals 0. So solving, we get 0, 4, and negative 1 for our solutions. So you've seen plenty of examples there of how to solve quadratic equations. Now I'm going to review you a little bit because of what we're going on to next. Do you remember, how do you find x-intercepts of a linear equation? Okay, first off, what is a linear equation? Linear equation is a polynomial where the highest degree of x is 1. So it might look like this, say 5x minus 10, for example. Okay, x-intercepts, they occur where y is equal to 0. Right, because they occur, let me draw you a little picture here. Here's your axes, there's your x-axis and your y-axis. If you have a line, say something like this, the x-intercepts are where it crosses the x-axis, and the value of y at that point is 0. Up here, you have positive y values, maybe 10. Down here, maybe you have some negative y values. But right here on the x-axis, the y value is 0. So when you're finding x-intercepts, you simply set y equal to 0. So I'm going to change that y to 0 and then solve for x. Okay, adding 10 to both sides, I get 10 equals 5x. Dividing both sides by 5, I get x equals 2. Okay, so that is the x-intercept. I believe when you enter your answer on MyMathLab, you'll have to enter it as a coordinate point. So if you're looking for an x-intercept, the coordinates of that point right there would be 2, 0. That's the x, y coordinate. So either of those, I'll accept either of these as an answer asking you for x-intercepts. I believe you have to enter it as a point on your homework and on the quizzes. Okay, let's do another one here. Let's find the y-intercepts of this equation. Try this one on your own first. X-intercepts. X-intercepts occur where y equals 0. So we have 0 equals 4x minus 6. So 6 equals 4x. Dividing both sides by 4, we have 6/4 equals x, which reduces to 3/2. Or you could say 3/2, 0. Okay, now, but we're not going to find x-intercepts of linear equations. We're actually going to find x-intercepts of quadratic equations, which is what we've been dealing with. Okay, so instead of having it equal to 0, you can always let that be y. So we have two variables here. What I want to do is find the x-intercepts of the graph of this function, and then what we're going to do is look at the graph of this function to confirm that we found the correct x-intercepts. Okay, x-intercepts occur at the same places. In other words, where y equals 0. So the first step in finding x-intercepts is to set y equal to 0. And then we'll solve for x. So let's see if this factors. So the 2x squared breaks down into 2x and x. Let's see. Now 15 could break down into 5 and 3. Let's try that first. I want to get a 7 in the middle, so I'm going to need, let's put the 5 with the 2 so that the outside terms will give us 10x. And then let's put the 3 here in the middle, so we'll get 10x and 3x. Then I just need to make them so that the 10x is negative and the 3x is positive, so that it adds to negative 7x. So that should work there. And then we set each factor equal to 0, so we have 2x plus 3 equals 0, and x minus 5 equals 0. So we have 2x equals negative 3, where x is negative 3/2. And over here we have x equals 5. Okay, so those should be the x-intercepts. And when we look at this, it might make more sense to think of this as negative 1.5 here. So it's going to be at negative 1.5 is where the graph should cross the x-axis. Now take a moment and graph it. I'm going to pull it up on a graphing calculator here on my computer for you to see. Okay, and here is the function here. So I'm going to hit enter, and there's its graph. Now I'm actually zoomed in too much here, as you can see. Hold on, I've got to drag it. Here we go. So I can see part of the function. It's right here, that gray line. It's very faint. And here you can see it. It does look like it crosses at 5 and negative 1.5. Let's see if we can zoom out so we can see the full thing. And there it is. Let's try this. There's the parabola. It's a little bit darker there. So it does cross here at 5 and negative 1.5. So those are the x-intercepts of the graph of this quadratic. Okay, so what is the graph of a quadratic called? That U shape that you saw, that's called a parabola. When you take college algebra, you're going to learn a whole lot more about parabolas and graphs of quadratic equations. There's tons of information about them that's useful. But we're just going to work on x-intercepts for now. So the x-intercepts of the graph of ax squared plus bx plus c equals y are the real number solutions of the equation where y is equal to 0. So where 0 equals ax squared plus bx plus c. And these solutions are also the x-intercepts to the graph of that function. So they're also the x-intercepts to the graph of y equals ax squared plus bx plus c. So that's it for solving quadratic equations. Tune in next time for applications where we're going to work some fun applied problems that involve solving quadratic equations to solve them.